Hello and welcome to this video about math. In this video I'll show you an intuitive proof that the square root of 2 is irrational, and this will work for the square root of any natural number that isn't already the square of another natural number. We'll prove this by contradiction. We'll make the square root of 2 equal to this fraction a over b, where a and b are positive integers. Then we'll square both sides, giving us this equation. A squared over b is 2 over 1. We can write 2 as a fraction unsimplified like this, because it prepares us for the next step. We can say that a squared is equal to 2 and b squared is 1. We'll call this result 1. So this looks a bit messy, but what it's really saying is that the fraction a over b is really equal to a product of primes over another product of primes. Any of these primes can be raised to a large integer power, even 1,000 or even 1,000,000. But the primes on top must never be equal to any of the primes underneath, because they cancel and would only remain on top or on bottom. In fact, none of the primes can be equal to each other. And now to square this fraction. And we'll get this fraction, which obviously has a larger denominator and numerator after we square it, because these numbers never cancel, because there's always different primes on top than on bottom. This is why this fraction can never be equal to 2. So we could already end the proof here, saying that a squared is always greater than 2 and b is always greater than 1. And so there's a contradiction, but this proof needs to be a bit more thorough. So I'll write these equations up the top here. We'll set a squared to be this, which is greater than the numerator of the unsquared fraction, which is equal to a. And we can similarly show that b squared is greater than b. Then we can write it out more directly. And we can then make this substitution for a squared and b squared from result 1. And then we can turn them around. So the only possibilities are that a can be 1 or 0 and b can only be 0, which isn't a positive integer and can't be a denominator. So the integers a and b can't exist, so this completes the proof. It's a proof by contradiction because we've eliminated all possible values for the integers a and b. So let's try plugging some numbers into this abstract equation. Here are some multiples of primes that give a good approximation for the square root of 2. We'll see why they can never be exactly equal to the square root of 2. I've used the indice to the power of 1 here to be consistent with the formula I've used. And here's what these numbers are when I calculate their numerical value. This is the fraction that closely approximates the square root of 2. So now we'll square this fraction, which gives us this fraction, which contains an even bigger numerator and denominator, since they don't cancel. The same primes are seen in the numerator and denominator of this fraction. Squaring a fraction always makes these numbers bigger. So we'll start with this equality. The numerator of the squared fraction is bigger than the original numerator. And so I'll complete this inequality. And we can do a similar thing with the denominator b. I'll just write these equations out with numerical values. So we can simplify these equations to give us these inequality equations. We'll substitute the values of a squared and b squared that we got from result 1 in the beginning of this video. And we'll make the variables into the subjects of these equations. I'll just rewrite these equations at the top of the screen here. And so the only possibilities for a and b are these. These values will never solve the equation, and 0 isn't a positive integer nor an acceptable value for the denominator. So no proper values for a and b can ever exist, and this completes the proof. There's no value for b that's even possible, and if b is equal to 1 was a possibility, then this would give us an answer of 1, which doesn't give us the square root of 2. So I hope that you've understood this proof and found it intuitive and exciting. Please click like and subscribe if you did. Feel free to share this video. Please leave some helpful and insightful thoughts in the comments, and thanks a lot for watching.